do you, so remember I'm doing this for those who do want to fail or for those who are stuck when they do the assessments. So I'll try to avoid some technical stuff. So those who are very advanced, please forgive me about that. So I'm going to minimize the video. I don't want to show you my Arsenal jersey, so that we always lose. I'm not a loser like our team. So enjoy. I think you can check out for more of my videos. So like what I said, I'm doing this. I read 4 statistics books. So I'm trying to explain what I understood, what I understand from that, and also try to answer or try to explain, kind of assuming the questions that most students who are quick or want to pass, they usually ask. So that's what I'm trying to do. I hope it will be effective and work for you. Okay, you can feel free to share with others. Yeah, thank you. So for this one, I'm going to do the person correlation. You must read this. I wish we remove this person name and we put maybe Rovu, Dube, Sibe, and all other local names, even Van, I've done something like that. These guys they did, but they were clever though. But I think one of us can also do the same. So yeah, so this pairs and correlation, don't confuse this with chi-square, because chi-square, remember we have a video that chi-square deals with data that in frequency, so in a kind of a tabulation, so that it's in categories. So the correlation, pairs and correlation, but in particular, it uses the data that is being measured at continuous levels. So for example, age and weight and something like that. So most people, they complain that my writing is ugly. So I did this, I typed this, and then I put a paper on top, and then I try like this. Let me try to be quicker. I like this video to be less than 10 minutes. So yeah, let's see if I can do that. I don't think so, because I wasted much of your time already. So what it does, the R, the correlation coefficient, the equation is degree to which X and Y vary together. And then the denominator, if you don't know the denominator, I can go and read somewhere else. So degree to which X and Y vary separately. So we see that most statistics, they use variance a lot, even t-test, even F ratio. So you must know what is variance and something like that. So what you do in exam, I don't know what I did here. I skipped something, okay, but it's okay. Let's say in exam you are given scores, X scores like this, and then Y scores like this. It sometimes not given written in an horizontal manner like this. They as in examiners or lecturers, they write even in a vertical way. So what you do first, you draw a table like this. You don't have to use a ruler. I remember in my mathematics exam, you see, what's that in the mathematical set? I was talking to my colleagues the other day. That thing where it's a pencil and a pin at the end, and then try to draw a circle. Let's say in exam, you see someone using that, and then you're confused. What's that for? So if you see people using a ruler in correlation exam, don't worry. Maybe they're trying to draw this table. But me, I'm not that CD. I can write. Remember my other tables, I was writing very ugly, but some people complain that my writing is ugly, so that they don't concentrate. So that's what I did. So we arranged the scores. So 5, 6. So these are the scores that we have. Remember, we are still using that fiction sort of hours of children watching the movie alone. So this is their age, and then this score of anxiety. So we want to see if there's a correlation between those two. So these are the scores. So we arrange like that, and then you calculate the deviations. So meaning that the mean for X is 7.73. So I rounded off all these numbers to 2 decimal places, and then the mean for the second one is 6.82. So so X minus mean. So this M is for the mean. Other text with the right, and X with a line on top. But I think writing an M like this is easy for most of you. So it means that 5 minus 7.82 2.73. So that's this. It's minus 2.3. You do the same here. 5 minus, so 6 minus 7.73. So you get this answer. And then 7 minus, you do that for this, like that. And then you go to for y, the deviation for y as well. So it means that the mean for that is 6.82. And then so it's 9 minus 6.82. So you get these values. You get these values until you do that. And then what is important is also you go through the square deviations for that. So it's very clear. You square. So if you are using a calculator in an exam, so it means that you square. So it means this number minus 2.73. You square that. So it means minus 273 times minus 273. So if you multiply two negative numbers, it becomes a positive. So you do that for so minus 7.3 times the same number. So you're going to get these numbers. And then we add that. So this is sum of squares for x. And then you do that for y. This 4.75 is coming from 2.18 times 2.18. So your calculator, you punch the number. I realize most students, they don't know how to do it. They know, okay, you want to square, but they don't know. Some of my students, few though, they punch on the square root. So that's not correct. You square that. So it means that 2.18 times 2.18. So you get these numbers. And then we add that. And then also what is important, the products. So it means that I'm supposed to move this for you. I do apologize. It was supposed to be in the same. So I don't want to confuse some of you. Some will understand, they'll get it, but so it's in the same line. So it's okay. So now it means that this xm, we have these values already. So this multiplied by this. So that's what it means. So if there are brackets, numbers in brackets, that's what it means. So it means minus 2.73 times 2.18, you get this. And then the second one is minus 1.73 times minus 0.82. So you get this. You do that, all the numbers, and then you add them. So it is minus, so I must explain this. If you are in exam, so it's minus 5 point plus this, and the answer minus this one, and then minus this one. And then so that is very tricky. You must be careful when you minus. It's like you're adding all the minuses, but the answer will go to, you must be careful there. So you punch minus, you punch the number, and then plus, and then minus, and then minus, and then plus, and then minus. You must be careful. So because you can easily not get the answer right, and then you can think that these videos or the lecturer was not very effective. So you must train and then practice. You practice and practice. You remember the equation for, I wrote the simple one here. So you can see in other textbooks they write a very fancy equation for correlation coefficient. So this R is an effect size. So let's not go there. So we have these numbers already. I wrote for you. So the SS and then the SSY. I was supposed to write X here. And then this Y must supposed to be subscript, but it's okay. And then SP, see there's a negative 20 here. So this is the equation. So we just need to substitute. So this is the equation for SP. Some people say, where did you get that? So if you do the same, you see another equation that I was talking about, this number on at the numerator. So it's sometimes confusing, but it's just a sum of products. So that's what it is. I think over. So you are substituting the numbers that we have. Let me just move it a little bit here so that you see what we are taking those numbers from. So this minus 20, that's the SP, we have it already. This one, we put it there. And then at the bottom is the square root of the SSX for X scores is this one, 54.18. And then I don't like this, what I'm doing. I don't like this gray thing, but it's okay. And then some people say I speak very soft. I'll try to be bubbly. Okay, let's move it. So the other one is 1.17.64. That's this. And then some of people say I skip some stages. I assume that people know. So I'm not going to skip a stage here. And then it means that at the bottom. So you multiply, if it's in brackets like this, means it's like 54.18 multiplied by 17.64. So that. So don't forget to square root. So what you do, you're using a calculator, you punch in 955.57, then do you click a calculator or press? Okay, you press on a square root, you're going to get 30.91. So you divide the two. So when you divide, also I've seen a lot of students, they type this first and then divide by. You don't do as you speak. So you type minus 20.55. You can ignore the negative, but don't forget to write the negative here. So it means that minus 25.5 and then divide by 30.91. Don't start by this one, okay? Please. Otherwise, you're not going to get it. So this is the answer. So you remember, if you check our the one that we did, okay, we did it together. I did it, but it's ours. So the answer was I think 0.67, if I'm not mistaken, because I rounded off to decimal place. I think it's okay like this. So it's minus. So it means that there's a negative direction. So this correlation is negative direction. What does it mean, negative direction? It means that as another variable increases, like this, as it increases, the other one decreases. So that's what a negative direction is. So if it's a positive, the values will go like this. Okay. Let's try to move it forward. And then you can also describe it like strength. So direction is negative, and then so if it's a positive, if there's no positive number, it's a positive direction. Strength, depending on the textbook that you are reading. So for those who use Pretoria's, those in South African Western Cape, UWC, there is a page where they explain that if you're using Field, Howell, or Gravita, they sometimes say just a strong correlation. So if it's between 6 and 7.6 is a strong correlation, and then more than 0.8 is a very strong correlation, and then there's a medium, and then there's a weak correlation. And then you can also describe it in terms of shared variance. So shared variance, that you square that number. So if you square 0.66 squared, you get 0.44, something like that. So you can do it in percentage value like this. So the shared variance 44.20. You can read what does it mean when I mean shared variance, something like that. So when I'm doing regression, this shared variance is going to encourage us to do multiple regression. And then significance, a number of textbooks, they speak a different language when it comes to significance. Some just compare the degrees of freedom of correlation, that n-2, and then the critical value they compare with this value. Sorry about these notifications. I don't want to miss some things happening back home. Okay, so they compare this and the critical value. I showed you a video. You can check on it. How do you check on those values at the back of text? But other advanced in the textbooks that I like, they compare the hypothesis. Remember that we are doing this correlation using a sample, but you want to be able to infer to the population, so generalize, so inferential statistics. So you can run a hypothesis on that. Is that okay? Is this correlation still the same with the population? Is it maybe not the same with the real population? So you use this equation. If you check the textbook, those are using Grafetta. I don't want this gray stuff. Okay, let me try to click to move out. So this is the equation. I don't know how did I scan my paper here. So it's T is equal to R minus P divided by square root of, in brackets, 1 minus R squared, and then also n-2 at the bottom. So n-2 is the degrees of freedom. So you just replace these values. So the R that we obtained, so that is minus 0.66 minus P is equal to 0, because we are saying the null hypothesis here is 0. And then in brackets 1 minus this. So it's going to be 3.34. Yes, 0.34 divided by the degrees of freedom. So you can compare now the number. If it's two-tailed, you check the T, the two at the back of the textbook, and then under 0.05, and then you can be able to say there is a significant, there is population correlation comparing with the sample that you obtained, or maybe there isn't, because there are so many factors, your correlation that you obtained. Maybe that's the problem, where we want to maybe generalize some of the test or some of the hypotheses that you obtain, maybe in America or in Africa, but you cannot always use it in the world. But it's happening like that. So we must do something and catch up. Yeah, I think, let me stop here before I confuse. So my focus was until here. So this is just a bonus and extra for us. You can read about it. And then maybe one of you is going to come up with we replace this person, and then maybe we decolonize this. There's a language about decolonizing. Let's start here. I understand that, but I think let's start to decolonize this and start with our own. Because if you see the Fisher, the Pearson, they're all guys from even the time, it's like 1958, 1927. And yeah, there's a good story about Pearson and Fisher. Also, there was a beef. Okay, thank you so much, guys. I don't want to waste much of your time. You can check out more of my videos. I'll share on Facebook, LinkedIn, and on YouTube, even Twitter. Thank you.